Hello, my name is Sierra and welcome to my channel, Homemade Mathematics. Today we're going to be taking a look at a strategy to solve for a side or an angle of a right triangle. This strategy is using our trig functions, sine, cosine, and tangent, and this little phrase we call Sohcahtoa. Maybe you've heard it before. Today I'll be explaining what Sohcahtoa is, how we use Sohcahtoa, and then we'll put it to work in some examples. We'll end with a real-world problem, so you can see how you could actually use this for things in the real world. So if any of that sounds interesting to you, keep watching. So to start, what is Sohcahtoa? Sohcahtoa is a saying that we use to set up our trigonometric ratios. So what I mean by that is, first we have so. Each one of these letters is representing some part of your triangle. Right? The first letter is the trig function you're using. So in this case, for so, we'd be using our sine function. Now your angle always goes with the trig function. So whatever your angle is would go here. We like to use the theta symbol. If you haven't seen that before, that is a symbol commonly used to represent an angle. And then that equals, so we have OH, which stands for opposite, over our hypotenuse, which we'll talk about how you find this part of it here in a second. Our next one is CAH, which is for our cosine function. So again, we're going to have cosine of our angle equals, and this time the A is going to stand for adjacent, and the H again, which we said stands for hypotenuse. And then our last one, TOA, we're going to use our tangent function. So tangent of our angle equals O, which we said stands for opposite, over A, which we said stands for adjacent. So now that we know what Sohcahtoa is, let's take a look at how we use Sohcahtoa. So depending on what you're given, it's going to depend on what function you use. Okay, depending on if you're given opposite and adjacent, you're going to use tangent. If you're given opposite and hypotenuse, you're going to use sine. So it depends on which sides you're given and which angle you're looking at. So the first side I want to talk about is our hypotenuse, because your hypotenuse is always in the same spot no matter what angle you're looking at. Your hypotenuse is the one across from the 90-degree angle. And what I mean by across is here's our 90 degrees. So if I were to go directly across that line that's across from that angle, that is our hypotenuse. All right, now your opposite and adjacent depends on what angle you're looking at. So for example, if I'm looking at this angle, right, let's say this is my theta, my opposite is going to be the one across, just like how my hypotenuse was across from my right angle. My opposite is across from the angle I'm looking at, so it's going to depend on which angle. But in this case, if I'm looking here, my opposite would be here, which leaves us with our last one, adjacent, which is the one next to our angle, but not the hypotenuse. So notice there's two sides next to my angle that I'm looking at. One of them is going to be your hypotenuse, the one across from the right angle. Your other one's your adjacent. But like I said, it's gonna depend on which angle you're looking at, because you can see if I were to instead look at this angle, that changes everything. All right, now this side would be my opposite, and this side would be my adjacent. Okay, so just depending on which angle you're looking at is your opposite and an adjacent, and then your hypotenuse is always across from that 90-degree angle. So now that we know what Sohcahtoa is, and we know how to use it, let's look at some examples. Okay, our first example here, we're given our angle of 32 degrees, and of course, our 90-degree angle. Remember, none of this works if it's not a right triangle. Okay, I do have another strategy that I love to use for triangles that are not 90 degrees, which there will be a video coming up on that. So if you're interested in seeing that, go ahead and subscribe. But that does not work if it's not 90 degrees. It is, so we're good. All right, so like I said, we're given this 32 degrees, and then we're trying to find this side, and we're given this side. So let's see, what are we given? Opposite, adjacent, or hypotenuse? And then what am I trying to find? Opposite, adjacent, or hypotenuse? That's going to determine what function we use. Okay, so if we're looking at this angle, this one is across. We're trying to find our opposite, and we're given the one across from our 90-degree angle, which remember that's always our hypotenuse. If I look over at my functions, Sohcahtoa, I'm given opposite and hypotenuse, O, so that means I am using my sine function. We're gonna go ahead and set this up. So I have sine, and then remember my angle always goes with my trig function. So sine of, we were given 32 degrees, equals opposite over hypotenuse. So my opposite was x, that's what we're trying to find. My hypotenuse was 7 inches. Once you have it set up, it's as easy as solving for x, right? We've been doing that in algebra forever. I'm trying to solve for x here. I have x divided by 7, so to get rid of that, we're going to take that times 7, so that we would get x equals the sine of 32 times 7. You're going to go ahead and type that into your calculator. Make sure your calculator is in degrees mode because you will get something different if it's in radians. So make sure you know how to do that. Also, a tip for those of you that use your iPhone calculator. First of all, I would probably download a different calculator because I've made so many mistakes just from using that calculator because it is very picky. But if you are, when you type your trig functions in, you have to type the angle first. So you would type 32 sine and then take that times 7, which we should have got 3.709. So I rounded that to 3.71. And then remember our label, this is a side, so our label would be inches. I always like to kind of double check and make sure my answer makes sense. Okay, so first of all, a lot of times if you're accidentally in the wrong mode and you get like an angle is 0.111 something, you definitely did something wrong. Go back and check. But if you get some really weird number, you probably know either you typed it in wrong or you set it up wrong. But another great strategy is using the knowledge that your angle is connected to the side it's across from. So what I mean by that is your smallest angle is going to be across from your smallest side, right? Your biggest angle is going to be across from your biggest side, right? That makes sense, right? If you have a bigger angle, it's going to be longer over there. If you have a smaller angle, it's going to be shorter across there. Okay, so we know that across from the 90 degrees, it was 7 inches. Now we're looking at 30 degrees, 32 degrees. So if I got 12, we know that doesn't make sense, right? Because 90 degrees got a 7, so we should expect something smaller, like 3.71. Let's try another one. Okay, with this next one, you can see we're trying to find x here, the side across from our right angle, which we know is our hypotenuse, right? So we know we're either using sine or cosine, depending on what the other side is that we're given. And if we're using this angle, right, our opposite would be across. So it's not our opposite, it's the other one next to it, which is our adjacent. Which trig function are we going to use for adjacent and hypotenuse? CAH, right, cosine, and we're going to set it up like this. Just like last time, once you have it set up, it's as simple as solving for x. You'll notice this time, though, our x is on bottom of our fraction. So we're going to multiply it to get it over to the other side first. So we'd have x times cosine. If we're trying to get x by itself, how to get rid of multiply by cosine of 56, we're going to divide by cosine. And again, we would just type that in our calculator. If you're using an iPhone, you have to be very careful when the trig function is on bottom. So if you are using an iPhone, how you would type this in, or a calculator that's very specific about how you type things in. If you're looking for a good calculator that is pretty simple to use, I would suggest Desmos. It's completely free. But if not, if you're using an iPhone or one that's kind of picky, a phone calculator maybe, you're going to type it in as 6 divided by, you're going to have to put in parentheses, 56 cosine, end parenthesis, enter. Because remember, when you are doing these trig functions with the iPhone, you have to type the degrees in first, which is another important part. Make sure it's in degrees, because I actually typed this in my calculator with radians, and I got 7.03, which is not correct because if you just type this in with degrees, you should have got 10.729, which I just rounded to 10.73, and it was a side. This time my label is feet. Okay, again, that answer makes sense because if you look here, the 6 feet, that's across from this angle, which if this is 90 and this is 56, 56 plus what would get us the other 90 because a triangle is 180 degrees total. So this angle would be 34, so 34 degrees was 6 feet. So we should expect 56 degrees to be more than that, 10.73 feet. Also, once you found that part, I forgot to mention this on the last one, but you can actually find all the other parts of your triangle now, right? Because like I said, we know it's going to be 180 degrees total, so we found that angle. And then we could use either Pythagorean theorem or we could use this strategy again to find our last side. Let's try one where this time we're finding the angle instead of the side because it is slightly different. We're going to set it up the same, but when we go to solve it, we're going to have one extra step. Let me show you what I mean. You can see this one is slightly different because this time instead of being given an angle and a side and finding a side, we're given two sides and we're being asked to find the angle. No worries though, we're still going to use these ratios over here and set it up the same and solve for x just like we were on those last two. Alright, so looking at the angle we're trying to find, we can see our 4 is our opposite and our 5 is next to it. Our hypotenuse would be across from the 90 degrees, so this one must be our adjacent. Which trig function uses opposite and adjacent? TOA, right? Tangent. So this time, we don't know the angle though. So instead of having tangent of some angle, we're going to have tangent of x, or tangent of theta, whatever you decide to use as your variable there. And then tangent is TOA, opposite over adjacent. Our opposite was 4 over 5, right? Which we should know 4/5 is just 0.8, or you could type it in your calculator, 4 divided by 5, you would get 0.8. All right, however, would it make sense for our angle to be 0.8 degrees? Probably not. But this is not telling us x equals 0.8. This is telling us tangent of x equals 0.8, which is very, very different. Okay, so if you think about when we're solving equations, to solve, we do the opposite, right? If we have plus 3, to get rid of it, we subtract 3. If we have times 12, to get rid of it, we divide by 12. So how do we get rid of tangent, or sine, or cosine? We use their inverse functions, which on your calculator will look like, it'll look just like usual, like this button here, except for it will have that -1 there. If you're using an iPhone or a phone calculator, you most likely will have to hit that second button, and then your sine, cosine, tangent will all turn to inverse sine, inverse cosine, inverse tangent. So we're going to just, in our calculators, we're going to do our 0.8 inverse tangent, right? So some common mistakes people make here is they forget we're finding the angle and they just use regular tangent, which if you just used regular tangent, if you did 4/5 tangent, you would get like 0.1. Another common mistake, which we talked about before, is using radians when we're in degrees, which if you did that, you would have got 0.67, which if you saw either of those answers, you would probably know right away, okay, I messed up somewhere. All right, but when we use that inverse tangent, we get our correct answer of 38.659. So I just rounded that to 38.66. And my label this time, it was not a side, which I didn't even give my sides labels, oops. But it was an angle. And we found the angle in degrees, so we need to put our degree sign on. Right? If it asked for it in radians, you would do this exact same thing. Set it up the exact same way. Except for in your calculator, you would have it in radians, and then your label, instead of degrees, would be radians. So you can see, if you know how to set these up, if you have Sohcahtoa memorized, you know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. If you know how to set these up It's as easy as 1, identifying what you're given. Are you given opposite and adjacent? Are you given hypotenuse and adjacent? Okay, so identifying what you're given, then 2, depending on what you're given, what function are you going to use? Set it up. Once it's set up, solve for x. That's it. So I'm going to go ahead and put 3 up on the board here for you to try. All right, we have 3 problems up here for you to try on your own first. So this first problem, we're finding our side when we're given an angle of 45 degrees and a side of 8 centimeters. Our second one, we're finding an angle where we're given 3 meters and 7 meters for our sides. So make sure you're using your inverse function as that last step on that one. And then number 3, we're given an angle and we're finding a side where one side is 12. Go ahead and pause, try those on your own, and then continue to see if you got them right. Since you should have tried these on your own, I'm going to go through them maybe a little bit quicker than I did those last 3. If you haven't tried it yet, pause it, try it first, just see if you can get it. Go back and watch those other ones another time. Just try and then see if they match what I got. Then you can see where those mistakes are that you're making. All right, our first one, we're looking at this angle, which we are given across from it, so opposite, and we're given next to it, but it's not across from our right angle, so it's not our hypotenuse, it's our adjacent. Which one uses opposite and adjacent? TOA, tangent of our angle, which is 45 degrees, equals opposite over adjacent. So our opposite was 8 over adjacent of x. Then once we have it set up, it's just solving for x. So we would multiply by x to get that off the bottom. To get x by itself, we would then have to divide by tangent of 45. Notice I'm not using inverse here because I'm dividing the whole thing by tangent of 45. I'm not trying to get this inside part, I'm getting rid of that whole thing. I'm not just getting rid of tangent, I'm getting rid of tangent of 45. That is an important thing to make sure you don't mix up. So we would end up having x equals 8 divided by tangent of 45, which if you're using an iPhone, you're going to want to do 8 divided by parenthesis 45 tangent end parenthesis enter, or find a better calculator that doesn't make you be so picky. And we should have got a nice 8, which then our label was centimeters, so 8 centimeters. Which now that you did the problem, you might notice, or maybe you noticed before, but we have 90 degrees, which if this is 45 degrees, right, these two should equal 90 together to get our total 180. If this is 45, that means this is 45. And remember how I talked about our angle goes with the side across from it? This angle was 45 degrees, it's across from 8. This angle is 45 degrees, it's also across from 8. Okay, that's actually one of our special triangles, which I will be making a video on as well. So again, subscribe so you don't miss those next ones. But now looking at 2, this time we're finding our angle, so we're going to have that extra step of using our inverse function. We are given the one across from it, opposite, and we are given the one across from our right angle, hypotenuse. So which one uses opposite and hypotenuse? So we're going to say sine of x equals opposite over hypotenuse, which we said our opposite was 3, our hypotenuse was 7, right? So in your calculator, you could go ahead and do 3 divided by 7 to get that as a decimal, but then remember to get rid of sine, right? We're not getting rid of sine of a number, we're getting rid of sine. So this time we are going to use our inverse function. So in your calculator, you're going to do the inverse sine of 3/7, which if you're using an iPhone, you're going to have to do 3 divided by 7 first, enter. Use that second button to turn your regular sine into inverse sine, and then you should get 25.38 about. And we should be in degrees mode, so our label is degrees. All right, and our last basic example over here, we have an angle of 38 degrees. We're given across from it, so we're given our opposite, and we're given next to it, but it's not our adjacent. This would be our adjacent. This one's across from our 90 degrees. So we're also given our hypotenuse, which uses opposite and hypotenuse, which we just said on our last one, opposite and hypotenuse, we're going to use sine. We're going to have to solve slightly different though because we're solving for a side instead of an angle this time, but we'll set it up the same. So sine of our angle, which we're given, is 38, equals, sine is opposite over hypotenuse, so our opposite is x, over our hypotenuse, which is 12. If we want to solve for x, to get rid of divide by 12, we would multiply by 12. So our x is going to be sine of 38 times 12. If you're using an iPhone, you're going to type in 38. Make sure you're using regular sign, get out of the inverse, times 12. 7.387, so I'm going to just round that to 7.4. And that was a side, so our label this time is inches. How did you do? Did you get all three of them right on your own, or where did you mess up? What step did you mess up? Make sure you don't do that next time. Okay, so see, it is helpful to pause, try them yourself first, because then you can really see what mistakes you're making. Okay, I did want to kind of end with a word problem or like a real life situation type of problem. So I'm going to put that up on the board next. So a common problem I see where you have to use this is where you're finding like the height of a tree or of a building or something like that. And you can actually use this to find the height of that really tall thing without actually having to measure it. Because we can use our trig functions to set that up. So what I mean is you might be given a word problem where it tells you you're this far away from this object, from this building. When you look up to the top of the building, it's at this angle, and then you can set up to find the height of the building or the tree or whatever it is. So let's say the problem here was that you are standing 12 feet away from a tree, right? And the angle from the top of that tree to the ground, let's say that angle is 36 degrees. That's enough information to now find the height of that tree. All right, so our tree is our x, right? This is our 90-degree angle where our tree hits the ground. So if we're looking at this angle, we're trying to find our opposite while we're given our adjacent, right? Because our hypotenuse would be across from our right angle. So we're given adjacent, we want to find opposite, which what uses opposite and adjacent? TOA, tangent. So we're going to have tangent of our angle, which is 36 degrees, equals opposite, which is x, over our adjacent, which is 12. Now we're solving for x. Times 12, times 12. So to type this one in, I'm doing 36 tangent, so I got 0.7265 times 12, I got 8.718, so we'll say 8.72, and my label was feet. Now what is that answer representing? That answer is the height of our tree, right? By knowing how far from the tree and the angle looking up at the tree, we were able to find the height of the tree without having to take out a measuring stick and take it to the top of the tree and measure it. I hope this video showed you what Sohcahtoa is, how to use it, and you feel confident solving any right triangle problem now using these functions. Again, I'm going to be making some more videos on triangles where they're not right triangles or are special right triangles. So if you're interested in those, please subscribe. I'm also collaborating with a website for this video. So if you're looking for additional resources on how to use Sohcahtoa, go to the website usesohcahtoa.com. I hope this video was helpful for you. If it was, please give it a thumbs up. Comment down below any questions you have or any requests you have for future videos. Thanks, and we'll see you next time.